Bismillahirrahmanirrahim. Dear students, today we are going to continue with our tutorial sheet 7. If you remember, last time I solved the problem 2 from the sheet 7. Today I will start with the problem 1 here. So it's more or less same, but the main difference between the two questions will be like previously when we solved it, we went through all the instruction cycle in order to fill the table here. In today's question, basically we will still be following that instruction cycle, but we are going to fill the table once an instruction has finished the execution here. So we are going to write the final values we get here. Okay, so let us start here reading and explaining the question here. First of all, he said that, for example, an instruction at an address 051. So it means we are given an address which is 051, and he said that this instruction is stored at 051 and has an I equal to 0. So whenever it is I equal to 0, it means this is a direct instruction here. Whenever I equal to 1, it will be an indirect instruction here. Now he said that this instruction is basically an instruction of and the address part in that instruction will be 093 here. And obviously all the numbers he is considering is an hexadecimal here. So basically, let me write it in the memory here. Basically, for example, I say that this is a memory here. Okay, in the memory, let's suppose we have different locations here, a lot of locations here. We have nothing to do with it right now. At certain location 051, okay, at 051, assuming this is an hexadecimal number, I'm getting an instruction here. So if you remember last time in one of the tutorial, we discussed about the instruction format here, where we are going to have a mode bit here, which is bit I here. In this case, the I will be equal to 0. Then we are going to have a code for an opcode here, operation. We call it as an opcode here. So in this case, this is an instruction here. And then finally, we are going to have an address part, which can be divided into a memory address as well as the register address here. In this case, he gives us the memory address. So the memory address in this case is 093. Okay. Now he said that the memory word at certain location 093. At 093, I have a memory word which contains an operand A8F2. So he said that at certain location, for example, 093, this is for example the location 093 in the memory. At this location, the number which I have is, or the data which I have is A8F2 here. So this is some memory word which is stored at location 093. Assuming all the values are in hexadecimal here. Now he said that go over the instruction cycle and determine the content of the following register. Sorry, another. He also said that the content of accumulator is F397 here. So it means that I have a register. Let's suppose this is my register here, which is an accumulator register here. He said that the content of accumulator is F397 here. Okay, now he said that go over the instruction cycle and determine the content of the following register at the end of the execute phase. So for the register PC, AR, DR, AC and IR, this is what we need to record after we finish with the execution here. So we want to record the values after we finish with the execution phase here. Okay, so let us start here. We will repeat it, okay, but let us start with the AND here. But before starting with the AND, let us suppose that what are my initial values here. So initially, what information is provided to us? First of all, he said that the content of accumulator is F397. So this is obviously given to you, F397 here. Okay, this is given to you, no problem here. Next thing is, if you see here, right now, this is the instruction which we want to execute here. For example, normally in a computer or in the computer basically, whenever my program counter is pointing towards an address, it means this is the address which it is going to execute next time. So right now, for example, it is executing an instruction. Next time it is going to execute the instruction of AND, which is given to you here. Okay, so this is the AND instruction which it should execute next time here. So it means that in my program counter initially it will be the value which is given to me. Okay, means right now I'm executing, or my computer is executing a different instruction here, but my program counter value is 051. So after it finished with that execution, it will start executing the instruction at 051, which will be the AND instruction, obviously. Okay, next thing is, if you see here in my instruction, the address part is 093. So it means this is certain memory address, and for if you need to access a memory, we need to have a value in my address register here. Okay, so this will be 093 will be my address register here, will be inside the address register here. So we have no information provided yet for the DR and no information for IR here. Okay, so this is my initial values here. By dash I mean like this is empty right now here. So now let us start executing our AND instruction here. Okay, now if you remember last time we referred to this table here, but there was another table also here, okay, that which was the complete instruction cycle here. But since we are right now not executing the complete instruction cycle, we are more focused on executing the specific commands here or instructions here. So let us just only execute here. So since I am executing AND here, so my focus will be only in this direction here. Okay, so this is what I'm going to execute right now here. First of all, if you see here what is happening, okay, first of all, remember, if you remember last time when we executed the instruction cycle here, in that one, maybe in I think T1 or T2, my program counter was incremented by 1. So normally each time whenever you are executing an instruction, your program counter will be incremented by 1 unless it is changed by the instruction here. Okay, so there are some branch instruction like BUN and BSA which may change the content of the program counter, but initially it will be incremented by 1. Okay, so in case of the AND instruction, definitely if you see here, my destination, it is DR here and AC here. Okay, and we are not recording SC here. So DR and AC are the only registers which are going to change the value. Otherwise, there will be no change in the other values here, other registers here. Okay, so what we do here, initially, my program counter will be incremented by 1. So it will be 052 here. Okay, again, this is an hexadecimal number. So you need to convert in binary. Then you add 1 and convert back in the hexadecimal here. Okay, so obviously it will become 052 here. Next thing is, if you see here, the instruction is I will be going to the memory at location which is present in my address register here. So this is basically memory memory at address register here. I am going to read the content. I'm going to read the content and put it in DR here. So if you see here, my address register value is 093. So I will go to 093. At 093, the content which I have is A8 F2, and this A8 F2 will go to DR. So it means this will be A8 F2 here. Okay, and obviously the value of address register is not changed here, as I told you previously that the destination registers are only DR and AC here. The next thing is, once we load a value in DR, we are going to perform an AND operation here. Okay, so this is your AND operation here. So we need to perform an AND operation here. So for AND operation, what we will do, we are going to perform the AND operation between the accumulator and data register value. So let me do it down here. Okay, so let's suppose my accumulator is F397 here. Okay, so let me convert it in the binary here. So F397 means when we convert from hexadecimal to binary, each alphabet or each digit which we have in the hexadecimal number will be transformed into 4-bit binary here. So 7 will be represented as 0, 1, 1, 1 here. 9 will be equal to 1, 0, 0, 1 here. Okay. Then 3 will be 0, 1, 1 here. And F is 1, 1, 1, and 1. Let me write here 1 here. Okay, and I think I did some mistake here. Yeah, it should be 4 bits. Okay, so this is your 7, this is your 9 here, and 3 will be 00. Okay, 3, this is your 3, and then this will be your 7 here. Okay, let me put a 0 here, and I can put 1 here. Similarly, the value inside my data register will be A8 F2 here. So let me rewrite it in the hexadecimal here. So 2 will be equal to 0010 here. F will be equal to 1111 here. 8 is basically equal to 1000 here. And A is basically 10. 10 will be equal to 1010, means 8 plus 2. 10 here, okay. And what we are doing, we are performing an AND operation here. Okay, so AND operation means the output will be 1 only if all the inputs are 1. Any single 0 will make it 0. So this is 0. This will be 1, 1 because both of them are 1. This is again 0, 0 here. This is 1. This is 0, 0, 1 here. This is 0, 0, 0, and this is 0 again. This will be 0, 1, 0, 1 here. So we convert back into the binary here, into the hexadecimal. So this is basically 2 here. This is your 9, this is 0 here, and this is basically 1010 is A here. So after we finish executing this one, the value of accumulator will be updated as A092 here. Okay, so this is how we execute. Now what we will be doing with the IR value here. So for IR, basically we will refer to this table here. If you see here, right now he said that I equal to 0, I mean this is a direct instruction here. And secondly, he said that I am executing an AND operation here. So if it is an AND operation, it means the code will be 0xxx here. So what we will be writing here, we will be writing 0, and this I'm just writing xxx here. What should be the value in this xxx here? It will be the value of your address register here, which is basically nothing but 0, 9, 3 here. Okay, why I am writing this value? Because if you remember last time in the executing the instruction cycle, we loaded, I think in T2 maybe, we loaded the value of instruction register from the memory. Then the first 11 bits were transferred into address register. So this is basically those 11 bits you can see. Clear? So basically what we have, it will be in the 0 will be coming from the table, and the remaining bits are coming from the address register, instruction register here. Okay. Now remember here, the remaining bits are coming from the address register. Now remember that basically we need to write the value of the address register, which will be our initial value, not the final value. Okay, because sometime in one of the instruction, the address register value will be changed by the instruction. So we are not going to write that new value, rather we will be writing the old and the initial value, which we have at the start of the instruction here. Okay, so this is what we have after AND instruction here. Now the question is repeat. Okay, repeat the problem 6 more times, starting with an operation code of another memory reference instruction here. So basically we need to start executing it again with another memory reference instruction here. Okay, 6 more times. So obviously it means we are going to execute this all table here, what we have. Okay, so now what we have, let us execute the add instruction here again. For each time we will be starting from the initial here, because we are repeating the problem here. Okay, so it means what we have initial value, we will be executing those values only. So let us start here. First of all, again, the program counter will be incremented by 1 here. So it will become 052 here from the initial, okay? Next thing is, if you see here, both of the instructions are more or less same. The only change is instead of and, we are just doing add here. Okay, this is MAR, this is means memory address register. Okay, so just assume it as the AR value here. So what we will have, we are not changing the value of AR, it will be 093 here. The only value what we will do, we will go to the memory, we will load the value and put it in DR. So what is the value we are loading? The address register is 093. So we are going to load A8F2 here. Okay, the next thing is we are going to update the value of accumulator by performing the addition operation here. So it means, let me just clean this one. Instead of and, we will perform add here. Okay, so everything will be same. So let me remove it here, this one. So basically what we have, 1 0 if I add them. Okay, so 1 0 will give me 1, 1 1 will give me 0 with 1 as carry here, 1 1 will give me 0 with 1 as carry here, so 1 0 0 will give me 1 here. Again 1 1 will give me 0 with 1 carry here, 0 with 1 carry, this is again 1 1, so 0 with 1 carry, so it's 1 1 1 which is equal to 3. 3 in binary is equal to 1 1, so it means 1 will come here and 1 will be carry here. So 1 1 is 0 again with 1 carry here, 1 1 is 0 again with 1 carry here, so it will be 1 here and 1 here. And then we have 1 0, 1 1 will give me 0 1 here, 1 1 will give me 0 1 here, 1 1 1 will give me 1 and 1 here. Since this is only 16-bit register, so we can exclude the last digit here. Now convert back in the hexadecimal, so this is basically equal to 9 here. This is equal to 8 here, the 4 bits, okay. This is equal to 8 plus 4 is 12. 12 will be ABC here, okay. And this is equal to 9 again here. So basically, after performing the addition operation between the AC and the DR value, the AC is updated as the new value, which is 9C89 here. Okay. And again for the IR, we will refer to this table again. This is a direct instruction and with 1 here. So it means what we can do here, we can put here 1, and again the value of AR is 093. So this will be A093 here. Okay, so let us go to the next instruction, which is LDA, load accumulator here. So LDA means again the value will be initially incremented by 1. I mean, we are again starting from the initial value here. Okay, so from 051 it will become 052 here. Next, what we are doing here basically, if you see here, we are just loading the value in DR here, first thing. Secondly, the DR value then we will update in AC. So it means again DR and AC are changing, the remaining are not changing with the previous, it will remain previous value. So it means it will be 093. So when we load at 093, the value is A8F2, which we are still doing previous, we did previously here. The value of accumulator will be the same value what we have in DR. So DR value will go to accumulator. So it means this is again A8F2 here. And from the table, it is true. So true. And the value of AR is 093 here. Next thing is STA, means store accumulator. If you see here in the store accumulator, basically, we are not storing any value in the register which we are recording. So we are not recording SC, and simply the value of accumulator will be stored in the memory location here. Means at the address register, which is 093, at this value, I'm going to store the value of accumulator, which will be F397. So this is the only instruction it is doing here. Okay. So basically what we do, if we start from the initial value, it will become 052 again, because from 051 incremented by 1, it will become 052 here. Next thing is the value of address register will remain as it is, 093 here. We have not loaded anything, so it will be still initial, like initial means empty, and this will have the previous value here. So basically we have not changed any values, only the program counter incremented by default, and the IR value will be updated with respect to the table, which is basically equal to 3093 here. Okay, the next one is BUN here, which is branch unconditional here. In case of branch unconditional, what we have, initially the value will be incremented by 1. So I'm just writing initially, okay, 052 here. Okay, but this will be changed again. Initially the value will be incremented by 1. Next thing is the value in address register is not changed, so it will be the initial value here what we have, and obviously this is what I have initially. Okay, I'll just write the initial values here. Now if you see here, the value of address register will be copied to the program counter here. So it means my program counter value will be changed here, and the incremented value will be replaced with the value of address register, which will be 093 here. Okay, and obviously we are not recording anything, so there is no DR here, and this will be obviously 4, and the initial value is 093 here. Okay, now the next thing here is basically BSA. BSA means branch and save the return address here. Okay, so again it will be incremented by 1 from 05, because I'm starting from the initial value here. Okay, so from 051 it will be initially incremented by 1 here. Okay, so it will become 052 here. Next thing is the address register is 093 initially, and this is F397. Okay, I just write with respect to the initial thing, only incrementing the value of program thing. Now let us execute the instruction here. What we will do, the program counter value will be stored in the memory location. So it means it will come to this location and store the value of the program counter, which will be the incremented value, which is 052. So it means it will store it as 0052 here, because my memory word is 12 bits here. Okay, so we are not recording the memory, so I'm not writing it here. Next thing is the value of address register is incremented by 1 here. So we will increment the value of the address register. So it will be +1, so it will become 094 here. Okay, next thing is he said that the address register value will be stored in the program counter. So it means my program counter will be updated with the incremented values. It means it will become 094 now here, so this will be cancelled here. Okay, so we have not recorded the DR, and obviously this will be equal to 5. Now what I want to tell, now we have 5, but initial value in my address register was 093 here. Okay, so I will just stick with the initial value. I'm not going to write the updated value here, because this step is performed before we have an address register updation here. Okay, so it will be 5093. So you need to write the initial value from which you have started here. Okay, next one is ISZ here, means increment and skip if 0 here. Skip means skip the next line in the instruction here. So what we have, again starting from 051, it will become 052 incremented by 1 here. Address register is 093 here. I'm just writing the initial values here. Data register is empty, and this is F397 here. Okay, so this is what I have initially. Let me remove this thing. The confusion here. Now basically what we are going to do here, first of all, we are going to go to the memory, read the value at the address register location, put it in DR here. So at address register means at 093, the value is A8F2. So we are going to put it in DR here. This is the initial thing here. Next thing is the value in my address register will be incremented by 1 here. This one, the value in the address, sorry, DR, okay. the value in the data register will be incremented by 1 here. So I need to increment the value with 1 here. So it means it will become A8 F3 here. Okay, so this value will be replaced with the incremented value here. Now what will happen? It will go to the memory and store this new value, updated value. So it means A8 F3 will be replaced here and it will be stored at this particular location here. Okay, so we are not recording the memories. I'm not doing it here. Next thing, I have a condition here. Now, if the value of dr is 0, is it 0? Obviously, it is not 0 here. So it means I'm going to skip this instruction here. If the value or condition is not satisfied, skip the next line and come out here. Okay. So it means the value, if dr is not 0, I'm not going to execute. Means I will skip the next instruction here. Okay. So in this case, it is not 0. So I will skip it and I will come out here. I will come to this here. I will come and jump to the next instruction here. Okay, by skipping one line here. So now the next one will be ISZ is 6 here. So I will have 6 and obviously the initial value is 093 of the address register. This is what we do here. So this is how we are going to fill it. Okay. Now the few variations here. Let me just explain the few variations. But let me remove this thing. Okay, in the same one, I mean just ISZ. Okay, let me use another pen here. Okay, in the ISZ, for example, somehow, okay, I don't know, somehow the value of, I'm just doing it with the black. Okay, somehow the value after the increment will become 000 here, for example. Okay, for example, initially my value here was maybe FFFF. Okay, so when we increment it by 1, so it will become 0000 here. Now, when we come here, if the value of dr is 0, yes, the value of dr is 0. So what we will do? We will increment the value of program counter. So it means my program counter will become 053 here. This will be an updated value here. Okay, the rest of the things will be same here. So it depends upon the condition. If the condition is satisfied, execute the next line here. If the condition is not satisfied, skip the next line and come to the next instruction here, which is the sequence counter equal to 0. I mean, we finish execution. Okay. So this was all about this question here. Okay. Now, it is quite possible that in the exam, instead of giving you let me just write. Instead of, he said that I equal to 0. Maybe he don't give you I equal to 0. He don't give you anything here. Rather, he said that an instruction at the address 051 in the basic computer has a direct instruction or is a direct instruction of AND. Okay, or he can say that, for example, an instruction or a direct instruction is stored at location 051, which is an AND instruction with blah 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 with the values here. Okay. Now, for example, instead of a direct instruction, he said that this is I equal to 1 here. He said that this is basically I equal to 1. Okay, but I think he should provide you with extra details also. For example, this is equal to I equal to 1 here. So obviously, if this is I equal to 1, this is not a direct instruction. This will be an indirect instruction here. Mean this value will be I equal to 1 then. Okay. Now, if it is indirect instruction, of course, we are going to get multiple addresses here, more addresses here. Okay. But just for example, for the current scenario, if only he changed from I equal to 0, he make it I equal to 1 with the same information, means he is not giving you any further details. But I think you should be given that details here. Okay. But one of the change which you will get with the indirect instruction will be coming from here. So instead of using a code 0, you will be using code 8, 9, A, B, C, D, E, depending upon the instruction, and the rest of the values will be same as what we did, means the initial values of address register here. Okay, so this is all what you have here, and most probably the quiz which I have announced for you next week, it will be from this tutorial sheet, inshallah. Okay, so thank you so much, and assalamu alaikum warahmatullah.